Yeah, we are on the air. So, Julian, while you are updating something, right, we can continue our...
Yeah, sure, continue the introductions, yeah.
Introductions, yeah.
So, yeah.
So, Andy, are you done?
Yes, I'm done, yes. So you go ahead, Vladimir.
Okay. So my name is Vladimir. I'm into performance stuff. My main job is regarding performance. I work with Java and Oracle database. So my area of interest in Calcite is like my areas of interests in Calcite is trying to make it useful for Eclipse Memory Analyzer, actually. So Eclipse Memory Analyzer is a tool that allows you to browse Java heap dumps, and I tried to use Calcite as a full SQL querying language for it. So I'm not quite there, but I really want some kind of indexed accesses to work properly.
Huh. Good. Well, it's good to hear too. There's the same requirement coming from several people. And on the subject of indexes, I mean, we can get to that later. But I hear that the Phoenix guys are really interested in optimizing queries for secondary indexes. So I don't know whether any of them are going to come to this call, but certainly interest from them. Okay. Let's see who else is. I see someone saying they're going to rejoin.
Hi guys, this is Siva.
Hi Siva.
Calling in from India. Hi Siva. Yeah, so yeah, I've only dabbled with Calcite. My background is I've done some SQL optimization stuff. I was part of the group that wrote Orca optimizer for the Premium database. Yeah, I work at Qbol right now. Qbol is like this big data platform in the cloud, supporting Hive, Presto, a couple of different SQL engines. And one of the things that is almost kind of does materialized view matching and goes to the right engine for the right query. So Calcite seemed like an interesting tool to build something like that. It's kind of fairly early stages, but I just want to get kind of familiarized with Calcite and see if it meets my needs. So.
Yeah, great. Yeah, I know the founders of. Well, I don't know the founders of Qbol very well, but a lot of the people in the Hive team know them very well. And yeah, I'd heard some rumors that Qbol was interested in materialized views, so that's great. I think materialized views are really exciting and important for analytic queries and Hadoop in particular.
Yeah, I'll switch off my video. Bandwidth isn't great here, so.
Okay. All right. Who else is on the call? Ethan, can you introduce yourself? All right. I'm not hearing anything from you. If you're still having sound problems, then well,
This is Trevor. Were you talking to me?
I was trying to talk to Ethan, but Trevor, go ahead.
Oh, okay. So my name is Trevor Hartman. I work for eBay, and we're working on a pretty new data management system. And so I'm getting into Calcite to add query support. So up till now, we've been writing queries in native Scala. So they're pretty verbose and pretty complex for people, especially if they don't know Scala. So that's what I'm working on.
Okay. Good. So thanks for introducing yourselves, everybody. Is it worth me? Hello? Ethan, I think you're trying to talk, but it's a very, very choppy line. I'm not really hearing very much from you. So you could try sending messages, and we see those on the screen. All right. Well, what about if we just dive into some specific questions? I have a presentation prepared, but it sounds like people want to dive in. So what about if we start off with Andy's question about views and, I'm sorry, about indexes, spend about 10 minutes on that, and then we can come back to it and spend more time in it at the end if we have more time. Okay, thanks, Ethan. I see you like that idea. All right. Okay, so Andy, tell us the problem and the approaches you were thinking of, and
Sure.
yeah.
So I guess first of all, I should say I don't really know the background of Calcite, where it came from particularly. So, but I found this, and it looks pretty amazing. We wanted to implement a couple of different types of joins, but initially a hash join between a table scan, which is actually a stream in our case, and then for each tuple we receive from the stream, we want to do a lookup in a table effectively using a primary key index and join the two tuples. So I was actually able to get that working really easily with Calcite. The only issue was it was performing a table scan of the table, and I haven't been able to figure out why that is or why it defaults to that. I'm sure there's a good reason, and yeah, I'd like to figure out how to make it use our index instead, so we can look up a single row for each tuple coming in from the stream, basically.
Yeah. Okay. Yeah. Well, to quickly answer the question where it came from, it originated in LucidDB, which was an open source data warehouse which had bitmap indexes and so forth. And also it was co-developed with the company I was in, which was SQL Stream, which was doing streaming SQL. And so, the kind of architects at those two companies had worked together before, and they realized that it would be better if we produced a shared technology and produced a reusable optimizer and reusable SQL parser and so forth, rather than trying to embed one. So it started off as a shared project between two companies, and SQL Stream moved away from it and stopped supporting open source. And LucidDB kind of became defunct as an open source project. It's just there are better alternatives these days. So I took LucidDB and the open source code, which by that time had moved to Apache license, and stripped it down. I took all the C and C++ code away and really just made it into a framework rather than an actual database, and removed everything that wasn't essential, which included the storage. I replaced the catalog with SPIs. I made the SQL parser optional. I made the JDBC driver optional. So what you were left with was basically relational algebra and a way of writing planner rules and a couple of engines for writing planner rules. and set myself an additional goal, which was to be able to produce, introduce this idea of a calling convention, to be able to access data in different, well, not formats exactly, but different query processing mechanisms. So access data in MongoDB or access data in remote JDBC data sources. So to be able to create a hybrid plan. So I did this by having a logical algebra which just represents, basically just represents a SQL statement, and have multiple physical algebras. So you've got, you know, a way of implementing a filter, the relational filter operator in Mongo convention or MySQL convention or enumerable convention, which means generating code to run inside the JVM. So that's what Calcite is. It arrived by stripping down something that was already there. And then I set about trying to get it to be used by various open source projects, and kind of having stripped it down to the minimum, then start to increase the requirements coverage so that it met the needs of various open source projects and commercial projects.
Cool. Thanks for that. That's very useful.
And then we entered Apache incubation about a year ago, actually almost exactly a year ago. So you know, really trying to broaden it out so it's you know, not just me and not just me calling the shots, but it's a community developing the code and making decisions. And we're up to I think about 10 committers now. Requirements coverage so that it met the needs of various open source projects and commercial projects. Can you repeat the question? And then we entered Apache incubation about a year ago, actually almost exactly a year ago. Hey, Ethan, I'm hearing your audio and it's me delayed. So Ethan, I'm gonna mute you. Okay. So Andy, you're talking about wanting to use indexes, which I presume are B-tree indexes. Is that right?
Sure, they are. Yeah.
Okay. So I talked about this with the Phoenix folks, and I believe this is I've never written an optimizer to deal with indexes. Because I've been involved in analytical databases most of my career. But I gather the classical way of doing it is to regard the indexes as a form of materialized view, which is to say that the optimizer knows that if you've got, for example, the employees table, and you've got a department number column in the employees table, and you've got an index on that column, then in a sense that index is a projection of the employees table with a different sort order. And so if you have a query which is select depno from emp, sort by depno, order by depno, then it just recognizes that really there's two places it can go for that data, and the index is one of them. And then if you've got a more complex query which is select depno comma name from emp, where depno between 20 and 40, then it recognizes that that is a range scan on the index, followed by a join to the employees table. And what is it joining on? Well, it's joining on this virtual column called row ID. Whatever you call the value in the B-tree index that allows you to get to a particular row of the employees table, and what that value looks like depends very much on the physical design of the database. But let's call it a row ID. Yeah, and then you can basically cost those two things. You can cost the scan of the emp table. It's going to have to be a full scan if the emp table is not sorted. And it can be a range scan of the index followed by a join to the employees table. Now, Now, quite how we would go about recognizing which indexes could be used, I'm not sure. But one interesting thing with materialized views is, so we're doing this with lattice queries and so forth. When you recognize you could use a materialized view, you're not actually you're using the capability of the Volcano planner to be able to say this expression and this expression are equivalent to each other. They will give the same results, and you don't actually have to choose between them. You can just say, you know, expression A and expression B produce the same results. Go and optimize them both, and choose the one which has the lower cost. And the way one does that in the Volcano planner is to put them into the same equivalent set. Expressions that are in the same equivalent set, that basically means they produce the same results for all possible data. I'm not quite sure whether you'd use, you know, strictly represent those indexes as materialized views, or if you can just use another mechanism to, you know, take that table scan query and convert it to a index lookup. But once it's there in the equivalent set, then the Volcano planner will then, you know, do what it does and choose the one with the lowest result.
Okay, that's great. And then I did try one approach. I had the idea that if there was a table scan that had a filter, maybe the filter is just a simple column name equals value, then when that's passed to kind of our engine, we can recognize that, okay, that column is actually indexed, and we can do, so we don't actually do a table scan, we can just go get that single tuple. So I don't know if that would make sense.
Yeah. I mean, let's suppose you have an index on depth. You might have various indexes.
Sure.
One on depno, comma gender, another one on, you know, marital status, comma depno. And if people are saying select a depno from emp, really any of those indexes is a sufficient projection to answer the query. So you don't have to have filters on that column to make it worthwhile using the index. It will obviously, the cost will be much, if there is a filter that's part of the leading edge of the index, then it will make it much more attractive. But in terms of what's possible, then yeah, it's just sufficient for the index to have all the columns you need. But yeah, you should be considering, if you're sorting on a particular column or if you're filtering on a particular column, then that's a good indication you should be considering that index. You could consider all indexes, you know, or all combinations of indexes could be valid, but yeah, probably you're most likely to get benefit for the ones that you're filtering on or sorting on. Then the other thing that happens is if you consider this as a join, then
it has to be a correlated join, right?
Exactly, it has to be a correlated join, because classical joins, they read all of the left side and all of the right side. You know,
Sure.
You can imagine they load them into hash tables or something.
Mm-hmm.
Whereas a correlated join will only start reading the right side, or actually I forget which way around do we correlate. Do we read the record?
Left side first, then we correlate to the right one.
I think so.
That's cool. And I'm only interested in correlated joins for sure.
Yeah, yeah. And correlated joins are correlations are difficult to optimize because normally when one because you need to take into account the number of restarts and the restart cost. I mean, in this case, it's just an index scan, presumably a range scan in the index, which is presumably quite fast. Right. But a correlated query in general could be doing a lot of stuff. and it's not enough to know that the cost of executing that thing is I don't know 10,000. You actually need to know how many times it's restarted. If it's only run once, then it has one cost, but if it's run 100 times, that's a different cost.
Sure.
So basically, that's just an estimation for the left side, right? We estimate the number of rows that was returned from the left side and
yeah,
number of restarts.
yeah.
There are lots of tricky items when you cost a correlated join or whatever index scan, but well, guys like PostgreSQL deal with that kind of issues for more than 10 or so years.
Yeah. So yeah, we can address it. I guess I should just say we don't have an existing solution in place because you'd be the first person that has done costing on restarts. And on the mailing list, I offered this other suggestion, which is it's something we did at Oracle when I was doing bitmap index queries in Oracle. And I think it's a good idea for just regular index use. If you have a variant of the table scan which takes a stream of row IDs into it, then the query doesn't, and this is useful for this particular case of a correlation where the right-hand side of the correlation is just a table scan. Is rather than making it look like a correlation where you've got this shape here where something comes from this side and it restarts that side, if you put this under here, then it becomes no longer correlated, and so your table scan is producing a stream of row IDs from the index, and those row IDs feed directly into the table scan, and it tells the table scan where to go next. So it's not a full table scan, it's a table scan which is driven by a sequence of row IDs. But it means you don't have to have a restart going on.
The problem with such approach is we don't yet support it, right? So we can't have such a, say, table function that consumes another table function.
Yeah, it would not be a table scan. It would be something,
Table accessed by row ID, right?
Yeah. It would be a new operator.
Not table scan, but table accessed by row ID. But anyway, it should be something like a table function that consumes, say, input and produces some output. We don't have such an operator yet.
Yeah, I wouldn't call it a table function because a table function is really something that looks like a table, but you give it parameters and it generates a table, and the parameters you only execute it once. Whereas this is a relational operator that happens to access a table, but it has an input. So I would say it's really just a new relational operator.
So you mean just any operator that takes a single input would work, right?
Yeah. And of course, the input has to be a single column. Well, the input has to return exactly it has to return row IDs, which will differ depending on the nature of the table. But in a lot of systems there'll be 64-bit ints or something. In other systems, I suppose they might be pairs of, a URI of a file and it will depend. It will change depending on how the system represents row IDs. And it's probably of interest to whoever's producing the row IDs. It's probably worthwhile making those row IDs assorted or at least localized. You don't want the disk head kind of you don't want to be doing random accesses. If you can sort the row IDs so that row IDs within the same block tend to occur in a batch, then your table scan, this table access thing will do a better job.
One of the things that we did was to normalize all the index stuff was to represent it as joins. So even simple filters would basically have a value scan. So if you had where x in 1, 2, 3, right? So on one side of the join, you just have a value scan 1, 2, 3, and you'd have a nested loop. So then it becomes normalized. There's just one way to represent all index access, which is via through nested loop joins. It kind of normalizes that.
Yeah. Hey, and what project was that in, Siva?
This was for Orca.
In Pivotal.
Yeah.
Right.
Yeah.
Okay. Yeah, I saw the Orca team present at SIGMOD last year, but I don't know many of the details. Anyway, that sounds like a good approach. So, Andy, does that help?
Yeah, it does help. It's I need to go do some more homework on this and try some more things. That definitely helps. Thanks.
Yeah, and I think you should create a Jira case, and it
So it looks like Julian is offline, right?
Yeah, it looks that way. So I guess while we're waiting for Julian, I'll go ahead and create a Jira ticket. And I would definitely like to try and help contribute to this, but I don't know enough about Calcite yet, so I'm still going through that learning curve.
Yeah, in fact, I did try to add some index access stuff. We have a reflective schema. Not sure if you saw that.
I've seen that, yeah.
Yeah, we have a reflective schema that tests just full scans, right? I did try to add indexed access, but it is quite a bit of work. So I dropped it.
Yeah, hello. Sorry, it crashed for me, but back in.
So Julian, I think you were about to say to create a Jira case, right?
Yeah, and Andy, I'd really like develop this in the open as much as you can, because I think the Phoenix developers, in particular Marianne Shu, she's facing a very similar problem right now, and if you could do it in a GitHub fork, or you could do it in a separate project. In fact, whatever you do, we can make it into kind of generic test cases inside Calcite. That don't depend on your database. I think it's generic functionality. So, and if I'm able to run through the unit tests that you write, I will be able to help much faster than if you're asking questions which look very abstract on the list.
Absolutely, yeah. Okay, no, appreciate that. So yeah, I mean, we have to implement joins in our products now anyway. Let me see what I can do to, and the code we have is starting to kind of mirror the Calcite design in some ways, because we do have this plan to move to it. So let me see what I can kind of make available.
Okay. And you mentioned streaming, and it kind of some bells went off in my head. I'm working with the SAMSA folks to do SAMSA SQL, and SAMSA tends to use key value stores to build kind of indexes and windows and so forth. So
yeah, I think we're probably quite aligned with what SAMSA are doing.
Yeah. So That's all right. I don't want to steal any of your IP. You can keep your trade secrets secret.
Sure.
But if we start seeing similar patterns, then let's just recognize them as similar patterns and solve them. Solve them in the best way for everybody.
No, agreed. That makes total sense.
Okay. Good. Well, let's move on. Whether I see we have Guillermo on the call. Guillermo, if you're able to speak and introduce yourself, that would be great. Hey, Guillermo.
Hi, how are you?
Good.
So, well, let me introduce myself. I've been looking into Calcite as a product we are developing, and just wanted to well get to know what you are up to, and try to keep track of features you are implementing, so we can perhaps switch, because we have a kind of a cache database for an analytics product. And we could like to use Calcite with a custom backend. And I've been looking into the CSV example and so on. It's a really interesting project. And now that you were talking about the B-tree indexes, I'm not really sure because I just joined a few minutes ago, but it sounds really interesting. And but I don't really have a lot of knowledge about the project yet, and just wanted to get a sense of what you are moving forward to.
Great. Well, feel free to just listen in and hear what we're doing. So, where are you based, and what company or project are you with?
Yes, I'm based in Spain, and I work for Video Analytics. And it's an analytics startup, and it's between an ETL tool and a data visualization application as well. It's somewhere in between.
All right, great. Well, so I recommend everyone on this call to join the developers list and just listen into what we're developing, and if there's a particular area of functionality, such as B-tree indexes, there'll be a Jira case, and you can subscribe to that Jira case and see activity that's going on there. That's a good way of finding out what's going on. And then, we'll have more hangouts. We'll figure out whether this is going to be weekly or monthly or whatever, but this will be an opportunity to ask stupid questions if you need to just, find out more about what's going on. But yeah, the list is the main place where stuff happens, so definitely get involved in that. We have about 18 minutes left, so are there any more questions? Maybe Trevor has something he'd like to discuss, design issue he's facing and wants to know how to do it in Calcite, or indeed Aman.
I had one question. So regarding compiled queries, it looks like the standard way to do it in Calcite is using link4j, which I believe it outputs actual Java code, which is then compiled with Janino. Is that correct?
Yeah.
Okay. So I don't have a lot of experience with dynamically producing bytecode, but the other way I've been looking into it to use in our own project was using ASM. And so I was curious if you had considered that, or what are the trade-offs between using Link4j or just the more low-level ASM?
Yeah, I think Vladimir and I have different perspectives on this. The reason I include enumerable, I don't claim that it is the fastest, most efficient way of executing queries. My goal for enumerable is to make everything possible, and it generates code in a functional style. You know, it's the same style as Link4j and indeed in Java streams and sorry, the same style as Link. But it's a functional style, which means it's generating a lot of GC. Every row is an object, and every time you evaluate a predicate, or indeed every time you put a row into a hash table, it calls a lambda in order to generate a key for that hash table. So it's an object-oriented style, which is not the most efficient in the world. So my goal with enumerable is to make everything possible. It's not by any means the only way we should be generating code. And the other battle I've been fighting is to make enumerable an optional part of Calcite, so that people such as Drill who really just they don't want to do code generation, they just want to produce the optimal plan for their engine, don't have to use enumerable at all. So given those constraints, I happen to use Link4j, which is really just a set of allows you to build an AST of Java code. You can generate Java code by building a parse tree, and then using Janino. Whereas if you use ASM, I believe you're working at the level of bytecodes. You're doing bytecode generation rather than generating Java code,
Right.
which means you probably can't use this functional programming idiom. I mean, if I was generating Java code for efficiency, I would be looking to get rid of the functional programming idiom altogether and be generating something similar to what Hive vectorization does, or what I think Spark has a new project called Tungsten, and Flink are doing a project which involves, they had a blog post about it this week, that involves generating native, off-heap data structures, and Drill do the same thing. So for efficiency of execution, I would be generating stuff that uses off-heap data structures, generates for loops rather than iterators and lambdas, and trying to get to zero malloc, to just work on byte buffers. So it's I guess I'd be generating what kind of looks like C code would be my kind of ideal environment. So it's doing big mallocs of off-heap byte buffers. It's using arrays of ints and very simple data structures. And yeah, I mean, I haven't even started. I don't know whether I ever would start, but that's where I would go if I was generating efficient code to run inside the JVM. And then, yeah, whether I would use Janino or ASM in order to generate that, I'm not sure. I think if I kind of was no longer generating functional style code, then a lot of the reasons that that make it attractive. If you're generating lambdas, it's very attractive to be generating Java code as opposed to bytecode.
Jordan,
Yeah.
we actually benefit from Janine a lot. We get quite good debugging information. So if it fails, we have clear explanation where it failed and what it was actually happened. We can actually copy and paste this generated code to the IDE to debug the query. So
that's true.
So this ASM stuff would be way harder to program, and it would be way harder to debug in both development time and runtime.
Yeah.
I wonder why Trevor doesn't suggest Scala expression generation. So as far as I know, in Scala, they have something like expression quotes, where you, so you know, we currently have to use link4j stuff to represent Java items. We can't just write a piece of code and tell the compiler to generate link4j stuff for it, right?
That's true. That's true. I believe the Spark. I believe Spark SQL are using quasi-quote functionality in Scala, where they can kind of represent an AST with very few lines of code and just substitute the parts of it they want to change. So yeah, any thoughts on that, Trevor? Have you looked at Scala expressions?
No, I'm not exactly sure what you mean by that. Scala expressions. I'll look it up.
I think quasi-quotes was the correct term for it.
Yeah. Yeah, quasi-quote was originally a Lisp thing, very useful if you're writing Lisp macros, because Lisp macros are so complex. You have to do a complex Lisp macro involves a lot of code generation.
Right.
So yeah, and quasi-quote is a way of writing a macro where 90% of it is the same, but you want to substitute in your own nodes into the AST.
Right. I did look into Scala macros, but I think the problem with that is that they are compile time, and I need it at runtime.
Yeah. So on the subject of efficiency, there's kind of two parameters there. One is how efficient is it at query prepare time, and I could possibly believe that generating ASM is just faster. You can get your queries running faster if you use ASM rather than going through Janino.
Right.
And then the question is runtime, where, as I said, I think potentially, if we had a different execution model where we were using for loops rather than iterators, then potentially there's massive benefits at runtime. But that's that involves a completely a lot of stuff rewritten from the ground up, or perhaps a new convention that uses for loops rather than iterators.
Okay, so I've actually started the ASM implementation, and I don't think it's going to be too bad because the queries are fairly small. Right now, I'm just trying to figure out how to do nested projection, but I'm making progress. I guess I was just wondering if kind of what your thoughts were on that, or if there's a standard way of doing it that you would suggest.
No, I've never actually been brave enough to, or I've never had time to look into ASM and what exactly it offers. But if you have an alternative to, so would you be generating this from the enumerable rels? Or do you have a new calling convention in mind?
I created a new calling convention kind of based on the Mongo adapter example, and I'm basically just extracting what the projections are into a nested Java list.
Okay. Well, that's totally valid, and I mean Calcite supports that pretty well. So. yeah, when you're able to share it, we could put it as a module inside Calcite, or it could be a separate project.
Okay.
It seems valid, and people might want to use it. And by the way, the nearest thing which is similar to it is the way Phoenix handles. Phoenix evaluates queries on both the client side and the server side. And the server side, in Phoenix's case, is code running inside HBase coprocessors. So they're generating HBase coprocessors execute something like an assembly language. I think they call it bytecode. Anyway, the code is represented in byte arrays. Yeah, they have an implementation of some of the simplest relational expressions like projects, filters, and some very simple aggregation that can actually happen inside HBase coprocessors.
Okay. Yeah, we'll see how it goes once I get to adding aggregation, filtering, and all that. But so far on projection, it's been okay. The other thing is we'll probably be open sourcing our data system by the end of the year. So at that point, I could actually show you what's going on.
Okay, good. Is there anything I can do to help?
At the moment, I think I'm okay, but I'll definitely let you know on the list if I have questions.
Yeah, okay, good. Yeah, I feel I've been able to give you very abstract advice on the list, but not being very concrete. But if it's working for you, then fine.
Yeah, it's been good, thanks.
Okay. We've got 5 minutes left. I wanted to have a plug for the upcoming release. So I adopted a kind of different process this time. Rather than issuing a first release candidate and having people find a bunch of obvious stuff, I asked people to. We officially entered stabilization on Friday, and I'm asking everyone to basically run the test suite in their environment, and if they're using it inside their own engine, to build the latest snapshot and try it in their engine. The Hive guys have done that, and I saw a message from Jesus on the list yesterday saying there was some assertion failures happening. So yeah, if you're using Calcite, please just try the latest snapshot and just see if there are any issues. And I'd like to resolve those before we go into the first release candidate, rather than having this thing where we have a 3-day vote, and then after 2.99 days someone raises an issue, then we have another vote, and after 2.99 days someone raises another issue. I'd rather get all of the issues out of the way, and hopefully the first release candidate vote will pass. Yeah, you could, if you have any dependencies on that Calcite, you can help by just doing that and logging bugs or sending emails. And then when the release candidate vote is open to everyone. You don't need to be a committer. Your vote is only binding if you are a committer. But really, anyone who's a contributor, and by virtue of being here, you're all contributors. So yeah, in Apache, everyone has a voice. So if the release candidate looks good, then give it a +1 vote. It's good to see a lot of +1s, from just regular contributors, just interested parties, because it helps create this feeling of consensus. There's always a question: how does one become a committer? One becomes a committer by being a contributor for a period of time and doing useful stuff. And that includes documentation, just being present on the lists. Obviously, code contributions help, but just going through the motions of being a committer and being a part of the community is how one becomes a committer. So please don't wait to be asked. Just jump in and participate, and the more voices, the better. That's about all I have.
Big question: was there any big roadmap items planned for, let's say, the next 6 months or a year?
Yeah, not really. In the sense that we are on this monthly release schedule, and so we tend to do what the roadmap is, whatever people choose to contribute. What I care about personally, I care about materialized views are a big thing for me, and we're starting. It's taken a while, but we're starting to think about doing materialized views in Hive. So as part of my day job, there's interest in making those. There's a lot of stuff in materialized views already, but making materialized views better is on my list. But no, there's no kind of big ticket items. So we're not aiming towards a big bang Calcite 2.0. I think you can expect a 1.1, 1.2, 1.3 monthly point releases, each of which has important, useful stuff that's important to the committers, and actually important to the community. So if the stuff, if Andy needs indexes and Andy helps work on index support, then that'll be in Calcite 1.4 or 1.5. So I guess the other area that I'm interested in is streaming, support for streaming. Not just Samza SQL, but other streaming systems. I was talking to the Flink guys, and interested in working on streaming SQL with them if they're interested. So those are my areas, but everyone is allowed to have their own agenda.
Just curious, does anybody have use Calcite to go from SQL to SQL, like after with some transformations? Is there reverse translation possible?
Yes. Yes. Yeah, there are some guys in persistence. I think they're based out of Malaysia. They are active on the list. They're particularly interested in using Avatica, which is the JDBC framework. But yeah, they've contributed JDBC Meta, which is actually it's not exactly the same question, but so they're interested in having an implementation of Avatica which works on an existing JDBC driver. But I believe there are also the JDBC adapter, which has existed for a long time and works very reliably, does exactly this relational algebra to SQL. So, for example, you can put Calcite on top of MySQL. You submit a Calcite query, it converts it into relational algebra, and then all the parts of it that it can push down to MySQL, it will convert that relational algebra back to MySQL, SQL in the MySQL dialect. And it does its best to produce a kind of nice-looking SQL statement. Its natural inclination is to produce something which is very, very deeply nested with lots of queries in the from clause and nested queries in the from clause. It tries to flatten that out as much as possible. There was a discussion on the list this week about scalar subqueries. That is a subquery in the select clause or the where clause, and how we don't do a very good job at reconstructing those scalar subqueries. The scalar subqueries are converted into joins in the relational algebra, and we're not smart enough to convert them back again to scalar subqueries.
Sorry, Jordan. I guess we are almost smart enough. So what's the problem actually?
Это папа Володя.
Hmm.
Папа Володя.
No.
Папа Володя.
Yeah, it's my 4-year-old
Папа
daughter.
Володя придумал.
So I think the discussion was if we were, say, if we want that to convert to Scalar subquery.
Папа Володя.
I think, Jordan, your opinion was, Scalar subqueries cannot be represented in relational algebra, so they must be avoided at any cost. Wasn't that, or I didn't get you correctly?
Yeah, I don't really want. I think having a scalar subquery basically means having a query that is a rel node tree in a project expression, which is just.
So you mean it is a bit weird in terms of it is not like an input, it is not like a join? Is it like that?
Yeah, it's not an input. It's a relational expression and a part of the tree that none of the rules are expecting to look for one. Project has one input, and so if you have a project with a scalar subquery, you've got a relational expression that isn't an input that's occurring in one of the expressions.
Yeah, but what if we represent it as a select single function, and in the adapter we recognize the pattern and push down as required?
Yeah, but then you lose the. Then it's then you've kind of hidden. You've got like a stowaway. You've hidden a relational expression, and none of the rules will see it.
You mean this function can be transformed way away? So some
Yeah. Well, for most purposes, you do want to represent the scalar subquery as a join. Because otherwise you've got this restart problem, right? It's correlated, and you'd have to re-execute it for every row. And often it does return just one row, so often you could represent it. The most efficient way to represent it is as a join. Allowing relational expressions inside scalar expressions is a major it increases the surface area of the relational algebra a lot. A lot of rules would have to be changed to look for these things. And given that scalar subqueries are relatively unusual, it just doesn't. Adding a new operator or a new concept to the relational algebra is a really costly thing.
Yeah, I see that. And what if we represent that as, say, projection with some function that takes this relational input?
Yeah, well, then you're kind of hiding it, which is
actually.
Okay.
So I'm not trying to hide it, actually. Well, I'm, but I'm not hiding it here.
Yeah.
What we do, we just project, we calculate the row, so it's right a natural projection, and well, the function can blame you if it encounters a couple of rows.
Yeah.
So that works. And the adapter can recognize the pattern.
Well, I think the canonical representation should be as a join. I mean, I guess I don't mind having another representation where it's a repped in a function. And maybe there's a way of going back from the join representation to the subquery representation. But I don't quite follow.
So the trickiest part is anyway to cost properly the expression.
Yeah.
So we need to know what is the cost of accessing such a Scalar subquery. So if we don't have any idea if the filter is indexed or not, we just don't have an option to create a good execution plan, right?
Yeah. Well, I'm worried we create the same situations we have with windowed aggregates, where we currently allow windowed aggregates to be in a project, and then we rewrite them away into a window relational expression. And the windowed aggregates are, they're not real scalar expressions, they are something different. And that confuses a lot of rules, like rules which push down filters through projects are illegal if there are windowed aggregates in the project. I worry that by allowing things which are not really scalar expressions, rules like pushing filters and combining two projects together might be broken.
Yeah, that's true.
Yeah.
You know that in Oracle database, Scalar subqueries introduce lots of limitations. I mean, if a query has a Scalar subquery, you can't go parallel.
Yeah. I wouldn't be surprised. They are difficult, and they are also just rare beasts. They don't, most people don't use them. So I don't want to. If scalar subqueries were really common, I would view this differently. But they're rare, and I don't want to compromise the rest of the system for them. I think if we can devise a way of maybe representing this, keeping the scalar subqueries as an alternate form, so that if we're pushing down a simple query to MySQL, we can recreate the scalar subqueries. I think that's worth thinking about. Anyway, we're well over time. I think we should have a discussion. I'd like to do another hangout. I promised people in let's say, the Far East time zones that we'd have a hangout in evening Pacific time. So, like 8 hours later than this one, or 6 hours later than this one. But I think we should have a discussion on the list about when the next hangout should be and whether this should be a regular thing. So, anyone have any closing remarks, or shall we end it?
So,
was it very helpful?
Yeah, thanks, guys. One quick question is there. You mentioned you had some slides, something that outlines the way the code is organized, and something to kind of help us get started. Was there any material that you can share that will just speed things along?
Yeah, if you go on SlideShare and search for the talk I gave at Strata in 2014 has just a general introduction to Calcite. Those slides are up on SlideShare. I think they're linked also from the readme.md, the main page on Calcite GitHub. So you can read those slides. It's a very high level, and I gave a talk recently, like a month ago, about why relational algebra is important. So talking a lot about relational algebra in general, but also talking about Calcite and the SPIs that are in Calcite. So you may find those useful. You may find that they're just too high level. Thanks, Vladimir. I see you have the SlideShare link there. Yeah, hopefully they're useful. I think next time we have a hangout, if people find it useful, we could actually dive into the code and write some. I could kind of show you how I go about writing Calcite code, how I write unit tests and run unit tests and use a debugger and so forth. I think that's kind of to do pair programming, basically. I think that's the kind of practical knowledge. That's the kind of practical answer to the question, how do I start? is I'd show people how I go about adding a new rule in Calcite, or how I go about extending the grammar or something like that. It's very difficult to communicate that knowledge in a slide given in a conference. I think it's better to just show you. Okay.
Great. Thanks. Thanks.
All right.
Thanks, Julian.
Thank you all for coming. And yeah, let's discuss on the list when we'd like to do this again. Great. Bye, everybody. Oh,
Bye.
thanks, Vladimir, for recording this.
Yeah, thank you.
Yep. Thanks,
Okay.
everyone. Bye.
Bye.